Professor Hyman here, IBUS 620. I'm going to talk about the descriptive statistics table, which in a research paper that involves regression is the first table you present, and it's just what it says. It's a descriptive summary of your data, variable by variable, measure by measure, the independent variables and then the dependent variable and then the control variables. Okay, you just give some summary information. There's a specific format that you have to follow. And again, a lot of this is not math difficult, it's formatting difficult in the sense that you already studied the math to calculate all this stuff. What you need to now do is know how to put it into a format. Let's talk about the whys and the wherefores first. I'm going to start up here. The example that I'm going to close this lecture with uses this data. So we're going to call it math test data, and it's out of 20. Out of 20 points, if you got 20 out of 20 on this math test, you got a perfect score. And there's a set of 10 different numbers here, and so you can pause the video, write down the numbers, and follow along and calculate these if you want, because I will have shown you some that I calculated a few measures for this variable here, the math test data variable. And now you can look at the data and you can run it yourself on a calculator or Excel or even by hand if you must. So we're going to talk about the descriptive statistics table. First, we're going to talk about why we're doing the descriptive statistics table, why it's a table, in fact, what is the format for reporting, and then we're going to turn to the example. So first, why descriptive statistics? We have to answer a question when we're doing an analytical paper that has inferential statistics in it. Remember, this is descriptive statistics. It doesn't tell us anything inferential about it. We can't test hypotheses with this, but it can tell us lots of useful stuff about our data. And specifically, we can use the descriptive statistics table, the summary statistics or summary descriptive statistics, those would be good names for the table, to answer this question: is it okay to proceed towards a regression analysis? Can we keep going? First thing you want to ask about this. So we use tables. Item 2, we use tables to summarize the data usefully and compactly. Okay, tables are easy to read, and there's an economy of communication with this table. It allows you to see at a glance what's going on with every single one of your variables. That's a really great thing. Number 3, format and reporting. We do it to conform to professional conform to professional reporting standards and conventions so that people who know what they're doing will believe us, because it's a familiar format to the industry of people who read other people's research. So you want to conform to your industry's standards, and this table meets those standards. Now, I'm going to jump up here to number 4, and that's got an A, B, and a C. 4A is this example we're going to start with from that data I showed you over to my left. Now we're looking at, here's the different data fields or the different variables that I measured here. Math test score, reading score, English writing, attendance, gender. Now let's just say what I'm looking at here is stuff I might want to put into a regression. And let's say these are international students applying for an MBA program, and the director of admissions in the US has to decide about what to do, admit or not admit, something like that. And they've got all this data. They've got the math test score off the GMAT, for instance. They've got a reading score, perhaps also off the GMAT. They've got the English writing score, which could be from the TOEFL or one of the other tests of English for non-native speakers. It's very international. We could look at, did you attend some seminars or something like that. We could look at the gender of the person, where we code 0 for male and 1 for female, and they would be giving that information on their application. And we might even code the starting salary of the person before they were applying for the MBA program. Maybe that's what their highest pay that they've received before the MBA program or something like that. You know, what's the salary you got at the beginning of the MBA program? Just a bunch of data here, and we could have some hypotheses about it, but that's another lecture. How do we organize this stuff? I'm going to show you for just the math test score, and it's exactly the same for all the other ones, so that's pretty easy, right? So you've got these column names: variable name, mean, SD, which is standard deviation. It's okay to abbreviate that. the minimum value of the data, the maximum value of the data. Min-max is good. The possible minimum value of the data, the possible maximum value of the data, the median, the mode, and the range of the data. Now, you just put those numbers in. I calculated the mean of that data set I showed you right at the beginning to be 14.5. The standard deviation is 3.57. The minimum data that's actually appearing in the data set is 8. The max is 20. Somebody got a perfect score. At least one person got a perfect score. We know since we peeked at the data earlier that there's only 120. So the min is 8 and the max is 20. The possible min is 0. It's possible somebody could have gotten none of the problems right on the math test. Don't admit that guy to the MBA program. Possible max is 20, so those are the same there, but highly different here. The minimum and the possible minimum kind of makes some sense. The median is 15. If you calculate it, you'll see it's 15. And the mode is also 15. There's two 15s. So the range then would be 8, 20 in the inclusive square brackets, the lowest data value to the highest data value, or you could say the range is 12. I discussed that in a different video, and I'm not a big fan of that approach, but you can use it. Here's an important hint is if you state the range using this notation, then you don't need to state the minimum and the maximum because it's clear that this is the same information as this. The notation and the headings are just different. Okay, so what I want to do now is move from 4b up to 4c, what the table tells us. Okay, and this is very important. This is why did we do all this? Okay, so one of the things we get is since the mean's 14.5 and the median and the mode are 15 and 15 respectively, one of the things we get is those values are really close together. You could even call them 3 15s, okay? So the mean is equal to roughly, let's put a little roughly sign up there. That's this over the equal sign. The mean is roughly equal to the median, which is equal to the mode. That tells us that the central tendency is at the data's midpoint, and that's kind of cool. That means that it increases the chance that it's actually a normal distribution. It increases the chance that it's a symmetrical distribution, and so we can assume that it's a normal distribution. So it's okay to do a regression from that perspective, but we're going to keep analyzing and investigating. But we move to the next step when we have this information about this variable. Okay, so the next thing you would do is you would look at the reading score, and I didn't calculate, I did not make up data for a fake reading test, but you could see you could just put those numbers here, and then for English writing you could put those numbers there, etc. for all of them. And once you're through, you've got a table that allows you to, at a glance, see whether it seems reasonable to proceed to a regression analysis. Things that would be red flags. This is the final topic here. Things that would be red flags would be if the standard deviation is really huge relative to the mean, then there may not be a clear central tendency. You can still put it in the regression, but I wouldn't get up your hopes that you're going to have a significant factor here, a statistically significant factor. The min-max one is interesting because let's say everything's all crowded between 16 and 20. That could indicate, so if this is 16 and this is 20, and it's a score out of 20, that could indicate that your test was too easy, right? That you have a problem with the test because you don't have very much variation between the min and the max. So that's, if they're close together, that's not so good either. You want a lot of variation in your data, okay? The fact that this is 8 and this is 0, the minimum and the possible minimum, that's sort of okay because, you know, people have a minimum level of math that's not, I can't do math at all, generally, if they're applying to an MBA program. And the median and the mode help you understand if you're way, way off or if the distribution of your data is roughly symmetrical. And since they're equal, both equal as we talked about earlier, roughly to the mean, that suggests we got a symmetrical set of data that approximately is normal, so we can assume normality. Now, n equals 10 data points is a pretty low number of data points, so I wouldn't go out and make regressions with data sets with n of 10 or even 20. I'd say 30 to 100 is going to be the minimum reasonable amount of data to do a regression with in the real world, and you generally want more data. But my example used 10 because it's quick and easy for me to calculate these, so you can follow along if you decide to use this data up here to kind of calculate these out and see what I'm talking about. The main thing you need to know is, though, how to construct this table. So how to set up the columns, what they should be called, and then calculate the quantities here, which you have already got in a previous instruction. So this is how to format it. This is how you present it in a research paper. You would put it on your PowerPoint if you were at a seminar presenting it to a group of industry captains, and they would be able to see this and look at it and understand it, most of them. So with that, I'm going to close, and I'm very pleased to have done this video for you, and I'll see you in the next video. Professor Hyman, IBUS 620. Take it easy.